Okay, welcome back. Let's take a look at the auto deploy architecture and several of the different ways we can deploy and walk through the process of what the auto deploy process does. So first things first, taking a look at the architecture is basically, it's a service inside vCenter, right? vCenter server is capable of running the auto deploy service. It's a service that's disabled by default. You enable it to make it available here, and it will have interactions with host profiles so that it can provide configurations to your ESX servers, and it should have access to the image profiles that were built and maintained through Image Builder. Usually the image profiles are held locally on the repository of the vCenter server. It is possible that the repository is stored in a more external location, but usually the image profiles are simply held right there in a repository on the vCenter system. So you have a collection of images, you'll have a collection of host profiles, and of course you've got the ESXi servers who need to be deployed. So an ESX server boots up, and one of the first things that's going to happen is it's going to do a boot request, and it's contain all of this. The request will contain a whole set of identifiers for that host. It'll contain the ESX server's IP address, because one thing about auto deploy, the ESX servers do need to be DHCP clients. So by the time they've connected to auto deploy, they've already received an IP address from their DHCP server. So they'll have an IP address, they'll have a MAC address, they'll have a serial number on their motherboard, they'll have a model number, make and model. They'll have all kinds of identifying attributes that when the boot request comes into auto deploy, a rules engine will then look to see, well, depending on what characteristic, depending on what type of criteria, will then determine which image the host is going to receive and which host profile is the ESX server to receive. Now, this is actually where things can be kind of interesting because, well, every host is going to have some unique settings when it comes to their network, right? So you'll end up having to create what are called host customizations for each and every single host that's going to be auto deployed so that we can gather not just the IP address for the management network, the host got that from their DHCP server, but they'll need an IP address for their vMotion network, they'll need an IP address for other VM kernel ports, and so on. All those host customizations are going to be uniquely defined for each host. So you'll have a rules engine probably determining which host profile for each host, probably based on their MAC address. That probably makes the most common sense, right? Where the image, on the other hand, it's more likely you'll end up having maybe just one shared image for a whole lot of different ESX servers. So you don't need to have a criteria based on the machine's MAC address to determine what image. You might end up having something that is more like what make and model hardware is the machine have that will determine which image they get. So you can create rules based on different criteria for what it is that we're needing to send down to that ESX server. MAC addresses probably make sense for host profiles, but then other criteria for maybe which image profile. Now it could be based on their IP address as well, because maybe because they're in a cluster, all the same systems in the same cluster, or all the different systems in the same cluster, they may end up having the same image. So it could be based on their IP address. That's however you see it working best for you. So the rules engine basically is the whole process of determining which thing to send down to the ESX servers, right? Which image and which host profile. So the image or the rules engine will map which software profiles and host profiles will be sent. Like I said, it usually is going to be based on either the MAC address or the IP address, but there are other few things that are available in the ESX server's boot request. And then once something's been fetched by auto deploy, it remains cached. So remember, these servers are stateless. The next time the server reboots, it's going to need all the same information. It's going to be cached in auto deploy to make the delivery, the subsequent boots, a bit faster. So to make this happen, there are some prerequisites. Like I mentioned, the ESXi host does need to be a DHCP client. There's nothing else that you can do here, right? The host is stateless, so it's not going to have a way to remember its IP address. Now, you're going to need to make sure in the DHCP server that there are DHCP reservations, because the ESX server can't get a new MAC address or a new IP address every time they boot. They need to have the same IP address every time they boot. So a DHCP server with DHCP reservations. Now, where you put this DHCP server is another decision. Can you use your current DHCP server that you're using for your organization? Or do you need to create a new DHCP server just for auto deploy use? That's going to be dependent on your environment. It just needs to be available on the management network. You'll need also a TFTP server, right? Because the actual a PXE file. Once an ESX server obtains their IP address, they will then do a TFTP download of the PXE file that basically tells the ESX server where to find the auto deploy server. So you do need a TFTP server to then host the PXE file that will be sent to every host. So typically a third-party TFTP server is needing to be implemented here. While vCenter appliance technically does have both a DHCP service and a TFTP service, those are not supported to be used for those purposes, right? The vCenter appliance is meant to be used solely to be a vCenter server, not also a DHCP server or a TFTP server. So you'll need third-party DHCP and TFTP services. So let's take a quick look at the overall process, right? Thinking of what happens when an ESX server who's an auto-deploy client, what's going to happen? Now, our picture here, we have over in the right-hand corner, we have an ESXi server who's about, or is in the middle of booting, right? Everything else to the left and above, that's all vCenter, right? So there's auto-deploy, that's vCenter. The image profile, that's stored in vCenter. The host profile, that's stored in vCenter. So this is basically primarily everything being handled by vCenter. Don't forget, the ESX server had to have booted and received two things. It should have received an IP address from this DHCP server, and it should have received a TFTP download of a PXE file. Now that it has the PXE file, that PXE file actually has in its encoding the IP address of the auto deploy server. Because where do you get this TFTP download PXE file? You actually get that from the vCenter server. So the vCenter server actually has a built-in TFTP folder that you would simply just download to your TFTP server, and then that file contains the information about the vCenter server's auto deploy server. So that's how the HTTP boot request actually gets started. The downloaded PXE file will actually tell the ESX server where to find the auto deploy server. So then it does that boot request. Now, on the auto deploy server, there is this rules engine that's waiting to learn about what are the different things about that ESXi server, right? That boot request will contain an IP address, a MAC address, serial number, make and model of the server itself. And then based on those criteria, you have a rule that will match this ESX server to an image, a host profile, and also where this host is to be located in the inventory. In this case, this host is going to be located in cluster B. That is then gathered and sent to the host, and that host will now effectively be imaged, configured, and will join the cluster. All right, all part of the auto deployment process. Now, don't forget, this is a stateless host. So if he reboots again, we start the whole process over. DHCP request, downloads the PXE image, the host will make the boot request once again. But since that host has booted once before, the image and all the other settings have already been cached, so they don't need to be fetched like they were the first time the host is booted. There'll be a quick comparison to see if there's been any changes, but it can immediately just download it, and the host basically joins the cluster once again. So, thinking about this, the stateful installation and stateless caching modes help minimize the dependency on vCenter in the PXE boot environment. What do we think about that? The stateful install and stateless caching modes, right? We haven't really talked about those in a lot of detail, but that is a true statement, right? Because what we're saying here is we don't necessarily need vCenter's uptime all the time to do those functions. What's the difference? Well, we'll take a look in our next lesson or in the next break. So we'll take a quick break here. We'll come back and talk about some of the additional elements and some of the other boot options that we have available. So stay tuned. We'll see you in a few minutes.